Yes. Hello everyone, myself Bharani. I am going to explain prediction of prices in Boston housing using linear regression. First of all, we have to import all the libraries that are used in Python, which are NumPy, Pandas, Matplotlib, sklearn.dataset for importing Boston housing data, and so on. Next, we have to use Boston dataset, which is already built in sklearn library, and we are loading the data using the function load_Boston function. And to find all the characteristics of Boston housing data, we need to use DESCR functions, and by using DESCR function in the print function, see, we have printed all the characteristics of Boston data sets, and by the result we can see that the number of instances are 506, number of attributes are 13, and here the attribute information is given, and so on. And next, yes. Here we are printing the data set as a data frame using Pandas data frame, and we print, if you want to, here we are printing all the data sets, that is Pandas data frame. Again, we are converting the target data into the data frame. To find the maximum and minimum values, use max and min functions. Next, we need to concatenate the features and target into a single data frame, and by default the concatenation is done by row wise. If you want the concatenation column wise, set the axis is equal to 1. So next we will visualize the relation between the features and target. So we use the describe functions, which provides the statistical information of the data set, and we need to round the data to 2 decimal points. That is, we have used the round.decimal is equal to 2 to set the precision to 2 decimal points. Next, here we have to find the attributes with the maximum correlation with the target value. We use Pearson correlation for this, and the correlation is nothing but how values in one columns are dependent on values of other column. So we need to find the correlation between every column of the data. So here we are finding the correlation between every attribute. Next, sort the list of the pairs in reverse order with the correlation values as the key of sorting. Now plot the correlation with respect to the target variable as the bar graph. We have taken the attribute values on the x-axis and correlation with the target values on y-axis, and by seeing the graph we conclude that LSTAT is the attribute which is strongly related to the correlation with the target values. And after finding the correlation value, we need to normalize the data. And the main goal of normalizing the data is to change the values such that after transformations all the values will be in one column scale. So we do that by using the fit_transform function, and reshape will do column wise reshaping. Now we'll define the error functions, and as we have the continuous data, we use mean square error. After finding the error, we need to split the data such that 80% of the data is the training data and 20% of the data is splitting data, and we achieve that using a function called as train underscore test underscore split function. Next, we will build the model which consists of an optimization algorithm, and the optimization algorithm consists of three functions, that is error function, update function and gradient function. The error function is used to compute the cost function values, and the update function is used to update the weights, and the gradient descent functions applies these gradient descent and cost functions and return the best fit for M and C values. So here we have written the update function for updating the weights, and next the gradient descent function which returns M value, C value, error values and MC values. Next, we need to visualize the training model. So for before visualizing the training model, we'll initialize the values of M, C, and the learning rate is equal to 0.01, iteration is equal to 250, error threshold is equal to 0.01. And when we plot the graph, we can see that the slope of the line is negative. By seeing this slope of the line negative, we can say that LSTAT value have negative impact on your target value. And in the next graph, we can see that as the number of iterations increases, the error value is getting decreased. So the next is prediction on test set. We need to predict the values, that is how the target values on the test set. So for that purpose, first of all, we are calculating the mean square error. We got the result as 0.0161, and next put the x value, y value and the predicted values into a single data frame, so that we can see all the values side by side. And if you see, these values are normalized values, which is of no use for us because we cannot predict the target value, the original target value here. So the original target values and predicted target values. So again we need to denormalize the data, and here we are denormalizing the data, and see we are getting our original values. Thank you.